All right, so today in class we started talking about functions. All right, and our definition for a function is that each input has exactly one output. And in class today we basically decided that input we can label as x and our output we can label as a y. All right, and that function can be anything. Usually, as far as math class goes, functions are equations. Okay, so we might have an equation. Um, our function might be x squared. Okay, so we're going to put in a value into our function. Okay, and then we're interested in what we get out of that. All right, so for example, we put in a 2, input 2, our output would be 4 because we would do 2 to the second power. Okay, so input is our x, output is our result, and then the function can be any equation that we are given. Simple as x squared all the way up to, any kind of formula you can come up with. All right. Now, so what our goal is for today is just to be able to identify in 7th grade. Our job is to be able to identify if something is a function. And there's several different ways we present these questions. One way is a simple mapping. All right. So we may have a group. So we may say our x, which again is our input. So we may say our input values are going to be 2, 3, and 4. And our y, which would be our output values, okay, could be 5, 6, 7, and 8. And so we would have a mapping. All right, we would have a mapping. And the question is, does this represent a function? Does each input have exactly one output? And so does this meet that criteria? 2 has 1, 3 has 1, 4 has 1. This is, yes, this is a function. All right. Doesn't matter that the 8 is not included. All right. Each input has one output. Okay, so that would be a function. And again, we could present several different varieties of the same thing. Okay. We could present several different varieties. Does this represent a function? Does each input have exactly one output? 3 has one output. 4 goes to the 8 and it's mapped to the 10. The 4 fails. So no, this is not a function because the 4 has 2 outputs, not 1. So that visual does not represent a function. Okay, and again, we could just continue to represent different mapping strategies here to see if you could evaluate whether it's a function or not. So that is one representation of functions that we need to be able to evaluate. Another representation of the same idea is with our graphing. Okay, we've been doing a lot of graphing in Chapter 10. Does graph A represent a function? So again, all we have to do is match that up against our definition. Does each x have exactly one y? Okay, so if we come over here, x has one dot at 1, 2, 3, 4, 5. So negative 5 up 4. There's only one there. Negative 2, 0. There's only one there. 0, negative 4. 2, 2. 4, 0. As I look through that graph, negative 5 only has one value matched with it, negative 2, 0. All of our x's only have one y, one corresponding y. So yes, this is a function. Represents a function because each x has exactly one y. All right, we come over here to graph B, more of the same. Negative 2, 0. 0, 4. 2, 4. 2, negative 3.
All core leaders, please go to the vocal music room at this time. Core leaders to the vocal music room.
Gotta love real life. All right, so as we go through and look, okay, hopefully these right here caught our attention. 2 is mapped with 4, and 2 is mapped with -3. So we have an x that has 2 outputs. So this is not a function. All right, not a function. It fails because of that there. So again, more of the same concept, just different representations of the same question. Okay, and then if we look down here, our final variable, or excuse me, our final setup that we could be presented with is an actual graph. And again, we have to just test. Graph C, is this a function? Does each input have exactly one output? And the best way you can do these, all right, if you look, our graph goes through here. So this x only, as you drop down through, you can see that no matter where I cross the x-axis, I'm only touching the graph in one spot. Okay, I can just keep going. All right, it's each one. Each x is only matched up with one y, so very simple. This is a function. Okay, if we come over here to graph D, all right, if we follow our y-axis down, boom, boom, 0, 2, 0, -2, okay, 3, 2, 3, -2. All right, we can see in lots of places, okay, that we have an input matched up with more than one output. So this graph is not a function. Okay, so hopefully that'll be enough to get you going here on the functions. Again, it's all about simple yes or no. All right, we just introduced functions in 7th grade, and hopefully this is enough to get you started on your homework. All right, bring any questions to class tomorrow. Have a good night.